Hey everyone, Plus2 here. We are doing level 3 differentiation 2024 today. I found this year many questions require certain skill sets like product rule and quotient rule. Uh, all right, let's dig in. Have a look at the first question 1A. It says differentiate f of x equals square root 4 minus 9x to the power of 4. So I recommend you change it to an index form, and then you differentiate. So this one requires chain rule, isn't it? So half comes front, 4 minus 9x to the power of 4 to the power of negative half times by inner. So the derivative of inner is minus 36x cubed, isn't it? And then when you simplify, half of negative 36 becomes minus 18 x cubed, and that one there can be written as square root of 4 minus 9x to the power of 4. Well, even you said minus 18 x cubed, say 4 minus 9x to the power of 4 to the power of negative half. That's correct. That's fine. But I like, writing in, third way. Now, question B. A curve is defined by the equation. Find the gradient of the tangent to this curve when x equals 0. So, obviously we have to differentiate. So this is product rule, isn't it? So the first one becomes u, second one is a v. You find the derivatives, and then it goes vu prime plus uv prime, or uv prime plus vu prime. So that is it. So easy question. Question 3. For the function below, find the range of values of x for which the function is decreasing. Yeah. So decreasing means what? The derivative is negative, isn't it? So obviously you have to differentiate the function. So the first one is required chain rule. So it's a 6 times the derivative of 2x minus 7 is 2, and 2x minus 7 to the power of 1, so you don't have to write, and plus 60 times ln x becomes 60 over x, isn't it? Because the derivative of ln x is 1 over x. So if I simplify this, 24x minus 84 plus 60 over x is negative. Then we change this to a quadratic inequality. Because of x is a positive, that inequality sign stays the same. So I got that. And then I can reduce to 2x squared minus 7x plus 5 is negative. So obviously I divide by 12 on both sides, right? And then I can factorize it. So it becomes x minus 1 times 2x minus 5 is negative. So I recommend that you draw this as a parabola, right? So the x-intercept is 1, 2.5. And because it's negative, so that region we are talking about, right, below x-axis. So to satisfy that condition, x must be in between 1 and 2.5 should be the answer. All right, next question D. Find the x values of any stationary points on the graph of the function below and determine their nature. So, well, to answer this question, you have to go all the way to a second derivative, isn't it? First derivative, you find stationary point, so turning points. And second derivative determines the nature of each turning point. And also, you can find a point of inflection. So first derivative, so to do so, because this is a product rule, u is 2x minus 1, b is e to the power of minus 2x. Hence, u prime is this, v prime is that, and y prime becomes that, right? Well, we are talking about stationary point. So we set that equals 0. And you know what? E to the power of 2x never becomes 0, isn't it? So that is, if I draw that, that is e to the power of 2x must be like this, right? So that means negative 4x plus 4 must be 0, right? So hence x is 1. And then we have to test what x, the nature of this stationary point. So second derivative. So again, because this is this requires quotient rule and u and v, and then you differentiate. So the formula for quotient rule is vu prime minus uv prime over v squared. That's what I did, and equals 0. What I did is I found a point of inflection, right? So second derivative equals 0 means that's a point of inflection. It turns out x is negative 1.5, right? And then also I test when x is 1, when I plug 1 into second derivative, so right here, I got this negative 4 over e to the e squared. So e squared is obviously positive. So negative over positive is negative. So that means when x is 1, it's a local maximum. And at x equals negative 1.5, it's a point of inflection. That's how you answer this question. All right, question E. A curve is defined by the equation there. So and then the curve has a point of inflection at the point P. Find the equation of the tangent to the curve at the point P. So what that means is you have to find the point P, and then you find the tangent at the point P. So first of all, I changed this into there because it's easier. You have to differentiate. Product rule is easier than quotient rule, right? And this is not even product rule. It's easier. Just use a power rule to differentiate. So I just split them. 2x squared over x becomes 2x, so on. So derivative is there, right? To find a point of inflection, as I said earlier, you have to go second derivative, right? So you differentiate this again and set it 0. It comes out negative 2 plus 2x equals 0. I'll explain this. So over here, I times by x cubed on both sides. That leaves a negative 2 plus 2x equals 0. Hence, x must be 1, right? So that means when x is 1, that's a point of inflection. And you have to find the y value as well. So when x is 1, y is 1 as well. So that is the point P, isn't it? And then, do you remember that we are finding tangent when x is 1? So find the gradient first. So when you plug 1 into the first derivative, it's 1. So gradient is 1. And because this line passing through 1, 1, so it turns out c is 0. Hence, the answer is y equals x, right? Awesome. Now, question 2. So a function is defined parametrically by the pair of equations. X is this, y is that. Find an expression for dy dx. So obviously you have to find dx dt, which is 60, right? And dy dt is minus sine t. So that's why this notation is very convenient. So to find the dy dx, you have to go dy dt times dt dx, isn't it? So minus sine t times, that's why it's 1 over 60, which is minus sine t over 60. Should be the answer. Question B. An object is traveling in a straight line. Its displacement in meters is given by the formula like this. T is in seconds. Find the velocity of this object when t equals 1 second. So kinematics question. So we have to find ds dt, which is the velocity, isn't it? So we differentiate. When you differentiate ln x, you get 1 over x, right? ln f of x becomes f prime x over fx, right? So I'm just gonna write. So say ln f of x, if I differentiate this, you get f prime x over f of x. So that's what I did. So I differentiate 3t squared plus 5t plus 2, which is 6t plus 5. And f of x itself is the denominator. And then you plug 1 into t, you get 11 over 10, so which is 1.1 meter per second. Okay, question C. Show that y equals sine x squared minus cosine x is a solution to the equation. So d squared y over dx squared, so second derivative, plus 4x squared y equals that. So obviously you have to find the second derivative. So first derivative first. So you get that, right? So, you know, dy dx gets 2x cosine x squared plus sine x, isn't it? Yeah, because the derivative of x squared is 2x. That's how you get the 2x cosine x squared. And when you differentiate cosine x, you get negative sine x. That's why it's plus sine x. And then when you do a second derivative, you have to use a product rule to differentiate, right? So 2x cosine x squared part becomes 2 cosine x squared minus 4x squared sine x squared. And then plus, when you differentiate sine x, you just simply get cosine x, right? So left-hand side, right? Left-hand side equals that, right? Yeah, because that's this second derivative, plus 4x squared, and then y is sine x squared minus cosine x. So you have to substitute there, and then you expand, and when you simplify and factorize it, you will get this, which is the right-hand side. Oops. Move this one here. Okay. Next question. Yeah, see? Lots of quotients and product rules. Consider the function f of x is ln x over x. Find the coordinates of the point of inflection on the graph of the function. So first derivative, 1 minus ln x over x squared, right? Because it's a quotient rule. U is ln x and v is x, and you get the derivative. So quotient rule is vu prime minus uv prime over v squared, isn't it? So that's the one. And then you differentiate again. So in this case, u is 1 minus ln x and v is x squared. Derivative is this, and second derivative is that. And because we are finding a point of inflection that's 0, that means denominator can't be 0. So the numerator should be 0, and that's 0. And you factorize it. X can't be 0, so ln x must be 3 over 2. That means x must be e to the power 1.5, right? So we found x value, so you have to find y value as well. So you plug e to the power 1.5 into original function, and you get 1.5 over e to the power 1.5, which is 0.335. So when you answer it, you can write like this, or you just say 1.5 over e to the power 1.5. Doesn't matter. So I'm saying that's the same as e to the power 1.5, comma 1.5 over e to the power 1.5. Okay, next one. question E. The graph of the function that, where k is non-zero constant, has a single turning point at Q. Find the x-coordinates of the point Q. This is, I would say, challenging question. So to find like a turning point first, you have to differentiate that, right? So quotient rule. Again, so uv and u prime v prime, and you get that, and because it's turning point sets 0, and then you will find um, e to the power of 3x bracket 6x squared plus 3kx plus k equals 0. E to the power of 3x can't be 0, right? Because it's exponent function. So inside the bracket must be 0, right? That's the only chance. So this quadratic must be 0. And do you remember? It has only a single turning point. So this quadratic equation has one solution. That means discriminant is 0, isn't it? That's why I said this. So b squared minus 4ac equals 0. So that means the k is 24/9. So we substitute 24/9 back to this quadratic equation. Just when you solve this, so I used graphics calculator. X turns out negative 2/3. All right. Okay. Next question. Question 3. Differentiate y equals square root of x secant 6x. So, well, that means u is a square root of x, right? Which is x to the power of half. Secant x, we need formula sheet. So if you see here, secant x becomes the secant x tangent x, right? Over here. So v prime becomes derivative of 6x is a 6, and secant 6x tangent 6x, right? So it becomes vu prime, yeah, plus uv prime, right? So that's how you get that, yeah. So when you do a vu prime, which is half secant 6x over 2, x to the power of negative half means over square root of x, right? That's why I write that way. And then vu prime is just simply 6 square root of x, secant 6x, and tangent 6x, right? Next question. The graph below shows the function y equals f of x. For the function above, find the values of x, where f of x is continuous but not differentiable. Now, continuous means, is easily speaking, whether you can draw the line without lifting up the pen. So in this case, because of this empty circle, at x is -1, I have to lift it up, right? And then carry on, right? And obviously here, I have to lift it up and carry on. So these are discontinuous, not continuous. Here says it's continuous but not differentiable. So this corner, sharp corner here, is not differentiable. You can't differentiate this kind of hard corner. So x is 5 is the answer, right? Now, question 2. For the function above, find the values of x where f prime x is 0. So that means a turning point, right? Stationary point. So over here, 1, right? When x is 1, that's gradient is 0, right? And also that part. So I'm going to show you again. Because this is, horizontal line, so the gradient is 0. So in between 3 and 5, when x is 3 and 5, between 3 and 5, the gradient is 0, right? So that should be the answer. What is the value of a limit f of x when x approaches -1? So that means when x approaches toward -1 from left to right and right to left, it approaches toward 1, isn't it? Yeah. So you have to say 1 is the answer. Question C. Find the values of any stationary points on the graph of the function there. Now, this question, I like to challenge the whoever wrote this question. Actually, you have to find a point of inflection or a point of inflections as well. But I don't think you can because that's too complicated. So I assume you can just find turning points, right? Not the point of inflections. Will give you a full mark. So let's find it out. So first of all, f prime x is there. So obviously this is a quotient rule, isn't it? Now, the reason why I did is I kind of wished I could factorize it, but I didn't find any common vector. So yeah, I tried, like I wanted to like simplify f prime x, but I couldn't. So I just go back to original function and simplified. So it turns out 10x squared minus 40 equals 0. I mean, because that fraction is 0, that means that the numerator should be 0, right? The numerator is 10x squared minus 40 equals 0. So then x is plus minus 2. So that's a stationary point. Now, I will just explain. To find a point of inflection or inflections, you have a point of inflection, right? You have to go second derivative. It's too much, to solve this question. So I do believe you can just answer this x equals to plus minus 2. That's, yeah, it asked for x values, right? So x equals to plus minus 2. All right, I think question D is the last question. Oh, no, it's not. Right, question D. This is a rate of change question, isn't it? Jim is doing some baking and pouring the flour to form a conical pile. The height of the pile is always the same as the diameter of the base of the cone. This is very important, isn't it? This year, actually, the question is easy. So that means h equals 2r. In other words, r equals h over 2, right? You need this relationship to be able to differentiate. If the flour is being added to a constant rate of 3 centimeter cubed per second, at what rate is the height increasing when the pile is 4 centimeters in height? All right, now you have to start with the question. You are finding dH dt, isn't it? So dH dt, and we have to use what we know. We know dV dt, which is a 3, times by, we can differentiate this, right? So dH dV. So, well, we will get dV dH, then you have to flip it over. So when you differentiate dV volume in terms of height, so that's why I changed R in terms of H, and you get there, and then you differentiate. So you get pi H squared over 4, right? So you plug them in. dV dt is 3, dH dV, so it's reciprocal of dV dH is 4 over pi H squared, so which is 12 pi H squared. Now what? So because it says when H is 4, so we plug 4 into H, so we get 3 over 4 pi, in other words, 0.239 centimeter per second is the answer. All right, the last question, I think it is the diagram below shows part of the graph of the function f of x is e to the power of negative x squared, where x is greater than or equal to 0. the point P lies on the curve and the point Q lies on the axis, so that OP equals PQ, where O is the origin. Prove that the largest possible area of the triangle OPQ is 1 over square root of 2E. I find this question easier than any previous exam question, this kind of this type of question. Yeah, because this it says OP equals PQ. This is an isosceles triangle, isn't it? That means if I say that point here X, then Q must be 2X, isn't it? Because it's midpoint. Yeah, right? So to find the area of this triangle, A is base times height times half, right? So half times base is 2X and height is Y value when X is X. So e to the power of negative X squared. So we simplify, we get X e to the power of negative X squared, right? So what do we do? So we have to differentiate this, meaning we have to use product rule to tackle this, right? So dA dx is that e to the power of negative x squared bracket 1 minus 2x squared. So I factorized it equals 0. So again, e to the power of negative x squared can't be 0. That means 1 minus 2x squared must be 0. That means x is square root of half. So x squared is half. X is a plus minus square root of half, but x can't be negative, so positive half, square root of half. So area is a square root of half, e to the power of negative half. So what I did is I just plug square root of half into this equation formula I made. So square root of half times e to the power of negative half, which means 1 over, because this is square root of 1, which is 1 over square root of 2, isn't it? So that's why it's 1 over square root of 2, and then e to the power of negative half is just square root of e down there. So which is just 1 over, you can combine them, isn't it? Square root of 2e. Finish the proof. All right. I will see you with integration maybe next time soon. All right. See you. Bye.